What is the technical process for Switch retro emulation? Imagine being able to run classic video games on modern hardware without the original console. This is the goal of retro emulation, and understanding the technical process behind it reveals a fascinating blend of software engineering and hardware mimicry. When it comes to emulating the Nintendo Switch, the process involves several complex steps that ensure games run smoothly and accurately. First, emulation begins with creating a software replica of the Switch's hardware architecture. This includes the central processing unit, graphics processing unit, memory modules, input-output systems, and other essential components. Developers analyze the original hardware specifications, often through documentation, reverse engineering, and hardware debugging tools, to understand how each component functions. Next, they develop a software layer called an emulator that mimics these hardware components. This involves writing code that can interpret the instructions meant for the Switch's processor and translate them into commands that the host system's hardware can understand. For example, the emulator's central processing unit core interprets the game's machine code, which is originally designed for the Switch's custom Nvidia Tegra X1 chip, and converts it into instructions compatible with the host system's processor. Graphics emulation is particularly intricate. The emulator must replicate the graphics pipeline, including rendering techniques, shader processing, and frame buffering. This often involves translating graphics commands from the Switch's graphics API into the host system's graphics API, such as translating Nvidia's proprietary commands into OpenGL or Vulkan calls. This process ensures that visual output remains faithful to the original experience. Memory management is another critical aspect. The emulator allocates and manages virtual memory spaces that mirror the Switch's memory architecture, including the system memory, video memory, and storage. It must also handle input from controllers, which involves translating input signals into actions within the emulated environment. Furthermore, to achieve compatibility and performance, developers optimize the emulator through techniques like dynamic recompilation, where parts of the game code are translated into the host system's native code on the fly. This reduces the processing overhead and improves game speed. Finally, extensive testing and debugging are essential to ensure that the emulation is accurate and stable. Developers compare the behavior of the emulator with the original hardware, adjusting timing, graphics rendering, and input handling as needed. In summary, the technical process of Switch retro emulation involves creating a detailed software replica of the console's hardware, translating and executing game instructions, rendering graphics faithfully, managing memory and input, and continuously refining performance and accuracy through sophisticated software techniques. This complex orchestration allows classic Nintendo Switch games to be experienced on a variety of modern systems.